Hello there, another look at exercise on simultaneous equations. Now you may recall at GCSE we did some simultaneous equations, and there were two different types actually. There was ones which you were told to basically eliminate the letter, I'm trying to spell eliminate up here, eliminate, and others that you use the method of substitution, and we're going to use the method of substitution on the whole today. That said, I would like you to try and do these simultaneous equations, and probably the easiest way to solve them is using substitution. I'm going to do the first one for you and I'll show you how to do that, but then after that I want you to try 2 and 3 on your own. So this first one, you'll notice the reason why this is slightly different is because one of the equations says y equals and the other one just says 3y plus 10x equals 7. Now usually at GCSE they were written like x plus 2y equals 9 and 3x minus 5y equals 22 or something like this, and I've made those numbers up. But usually and this was the ones where you did a bit of multiplying of each equation, you got rid of one of the letters, and that's why it was called using the method of elimination. You got rid of one of the letters. Here the method of substitution is basically where we say y equals this. So when it says 3y plus 10x is 7, I can write 3y. Well, y is 2x plus 1, so I put it in a bracket and I go 3y. That's 3 lots of 2x plus 1. Don't forget the 10x. Don't forget the equals 7. And effectively, now I've sorted it. Just got to solve this equation. Multiply out the brackets. I get 6x plus 3 plus 10x equals 7. That's 16x. I reckon it's 4. Move the x over. I reckon I'll get x equals a quarter. 4 divided by 16 essentially. And to get the y, you can go into the equation you didn't use very much. This one says y equals 2x plus 1. That's 2 quarters or a half plus 1. I reckon that's 1.5. Probably better written as 3 over 2. So that's my solution. I haven't checked it yet, but I want you to try and do question 2 and question 3, also using the method of substitution. See if you can do it. Well, hopefully you've paused the video. Hopefully you've got some answers. The last one is a bit different because it said y equals that and y equals this. So theoretically you've just gone 4x plus 5 equals 3x plus 6. Hopefully you've done that. Question 2 is much more like the one I did. Here's the answers anyway. Answers. A quarter and 1.5. I've got that right at least. 10 and minus 1. Hopefully you've got that right. And 3 is x equals 1 and y equals 9. If you didn't get them right, go back and check them. Do them again. Get the right answers. Simultaneous equations then, but this is a method of substitution. The difference now will be that one of our equations will be a curve. There won't be 2 straight lines. So what you were effectively doing at GCSE, you had one equation which may look like that, you had another equation that looked like that, and you were really asked, where do these 2 lines cross? And that's why when you did this, the 2 lines cross there. And this is what you find. You find that x equals something and y equals something else. That's what you were doing. But what we're looking at A level, much more so anyway, is the fact that one of them may well be a quadratic curve. And you may get a straight line like that. And you're trying to solve these 2 equations. And you're trying to solve them using the method of probably substitution. But you'll notice now, this is my quadratic. And this is my linear, my straight line. And so I'll do some examples. That will give me a straight line, a linear, and this will give me a quadratic. Y equals x squared. Notice the quadratics will always have x squared to them. Linears won't. So the easiest way is by the method of substitution. And let's get on and do it. So I've got this equation which I've just mentioned. Notice again, it says y equals this and y equals that. Whenever you get that, just set this equal to that. So I'm going to say x squared equals 3 minus 2x. Easiest way by far. If they ever are kind enough to give you y equals something and y equals something else, set the 2 things equal to each other. Now this is a quadratic, so I'm making them equal to 0. X squared plus the 2x minus 3 equals 0. Of course you could chuck that into your calculator, you could factorize it. I'm going to factorize. I reckon it's x plus 3 and x minus 1. But if you did that on your calculator, you would get exactly the same answers. You would end up with x equals minus 3 or x equals positive 1. Now bearing those in mind, that only gives me the x numbers. So choose one of the equations. This one looks the easiest one. So if I want y, it's minus 3 squared, because it says y equals x squared. 9. And if I do this one, y equals x squared again, that's 1. Notice it wants a coordinate, so I'm going to write them as coordinates. Minus 3, 9. That's my first pairing, these two. And my second pairing is there, 1, 1. I think they are my answers. Interestingly, I've drawn a picture of this. I didn't know I'd drawn that. There's the 1, 1. That's crossing this line down here, crossing my curve here. And the other one is at minus 3, 9. Yeah, that kind of works. And notice the way it's a curve and a straight line. So I'm happy with that. Second equation. Notice this says rearrange. It wants me to rearrange it, possibly anyway. I might have to just do a little bit more work. Might not have to, but we'll see. It says solve these simultaneous equations. Exactly the same issue. One's a quadratic and one's a linear. Now, if they don't say y equals this and y equals that, I just got to do a little bit more work, because this one is the easiest one of the two to rearrange. So I'm just going to make this say y equals. And I'm going to think of that as moving over and that moving back again. So I reckon that become plus y, that become minus y. I reckon y equals 2x minus 1. Now I know that. This is easy. I can go, y. Now I can do it. 2x minus 1 equals x squared minus 3x plus 5. So as a general rule, we try to rearrange the easier of the two functions. In this case, it's always the linear function. Now I've got this, I do the same thing. I'll try to make it equal to 0, so I'm going to move all of this stuff over there. I reckon I get x squared. Those will become minus 2x, which make it minus 5x. That will make it plus 1, which will make it plus 6. And it should be equal to 0 over there. But I'm just going to write it there. That was plus 6, and that's a proper 6. I don't know why it looked like a minus. So I factorise. Same as last time. I reckon 3 and 2, but it's a minus in the middle, so it'll be x minus 3x minus 2 equals 0, and therefore x equals 3, or x equals 2. Use my y equation. Here it is 1. This looks like the easiest one. I've got to double it and take away 1. That's doubled is 6, take away 1 is 5. Doubled is 4, take away 1 is 3. And this one just says solve. So I'm just going to leave it like that. It doesn't want coordinates, so I'm just going to write it like that. What's it say? X equals 2 and y equals 3. Yep, got that. And x equals 3 when y is 5. I've got that. Did I draw the graph on that one? No, I didn't draw the graph. So again, we've got another one to solve. And again, it's suggesting rearrangement might be useful. And I think it's more useful in this one because this is more confusing. This is actually, it's not a circle. This is actually called an ellipse. So it's not even a quadratic, but you can see there's squared things in it. And when there's squared things in it, you've got a bit more work to do. So we're going to rearrange this one. This one might be best to rearrange as x equals. You can see it's sitting there on its own. So I'm going to do that. I'm going to move the 2y over and 4 minus 2y. Notice I'm going to use the same trick. But this time, because I've written x equals, I've got to find places where it says x in this one. So it's easy enough. It's 2 times by x squared, and because I've got x is equal to this, I'm going to write 4 minus 2y squared plus y squared equals 9. Finish off the equation. Now, got to be careful, because this could go wrong if you're not careful. This basically means 4 minus 2y times by 4 minus 2y, and then times everything you've got by 2. So, when I do that multiplication, don't forget the 2 times at the front. The 4 4s are 16. 4 lots of 2y is 8y, or minus 8y, but then there's another one there as well. You get this same thing twice. So I get that one and this one. So I reckon it's minus 16y, and minus 2y times minus 2y, be careful, plus 4y squared, plus another y squared, equals 9. Multiply everything out, get rid of the brackets. 32 minus 32y plus 8y squared, plus another y squared equals 9. So we're getting close now. I reckon I've got 9y squared, that's then dealt with, minus 32y. Now it says 32, but I'm going to have to move that 9 over, so I end up with equal to 0. And I reckon if I do that, what's that? Plus 23. Well, that's not very nice, is it? Can I factorise it? Well, probably, but again, such horrible numbers, I'm going to get the calculator. Might as well, got a calculator button to cheat with. So go down to A, solve this, what are they? It's a polynomial equation now. And it's quadratic, so at degree 2. And my numbers are, what are they? 9, negative 32, and 23. And I get some not very nice answers. So I get y equals 23 over 9. Is there a nicer answer with it? Yeah, y equals 1. Now, that's only the y coordinate, so I want x numbers as well. X is equal, now, but just put it into here. Well, I might as well do the easy one first. X is 4 minus 2y. 4 minus 2 ones sounds like 2 to me. And I'm going to do this on the calculator. I don't want to make daft mistakes. So I'm going to do 4 minus 2 times 23 over 9. And it says minus 10 ninths. They're not very nice answers. Effectively, I've got a coordinate of 2, 1. I've got another coordinate of minus 10 ninths, 23 ninths. What do you want to graph? Yes, I have. Oh, right. That, then, is the nasty one, the minus 10 ninths, 23 ninths. Yeah, it sounds about right. And 2, 1, yeah. And see this elliptical shape? This is like, some people call this an oval. But it's actually an ellipse, and the answer's right. Not very nice, but there you are. And that's it. We've finished the prep for exercise 5A. In class, we will do more of these. We'll practice, maybe do a couple more on the board, and then you will have to do these. So I hope that makes sense, and we should be okay in class.